says for part A, use the cosine rule in triangle BCM to find cosine of theta in terms of A, C, and M. Here is C, B, M in this triangle. Cosine of theta, we see theta is between M and C. So if I want to use a rule, I say A squared equals C squared plus M squared minus 2cm cosine of theta. Now to write the cosine rule, to make cosine of theta object, I say cosine of theta equals, I bring C and M in the other side, so it would be A squared minus C squared minus M squared over negative twice C times M, product of C and M. So it's the one that part A asks to find. Now I will go for part B. For part B, it says use the cosine rule in triangle ACM to find cosine of 180 minus theta in terms of B, C, and M. Let me change my color. Here for this triangle ACM, I am gonna find the cosine of this angle 180 minus theta. So 180 minus theta between C and M is between C and M. So I start to write a cosine rule that says B squared equals C squared plus M squared minus twice the product of C and M and times cosine of the angle between them, which is 180 minus theta. Now I make cosine of 180 minus theta my object here in this formula, so I write the formula for cosine of 180 minus theta, which is, I bring two terms, C squared and M squared in the other side, would be B squared minus, I take a negative sign factor, so no, let me write as it is, so minus C squared minus squared over negative 2cm. So it's my part 2, and the answer of part B, I will go for part C. For part C, it says, let me change my color. For part C, it says, use the supplementary angle formula. Cosine 180 minus theta equals negative cosine theta to prove this theorem. So I try to use a unit circle. So I try to use unit circle that says, if I have here this point, and I reflect this point across the y-axis, my x becomes negative x, but my y doesn't change. For unit circle, we know my x is cosine and my y is sine. And if this angle is theta, so when I reflect it across the y-axis, this angle would be 180 minus theta. So as I said, my x is cosine. So I reflect it, my x becomes negative x, so it would be negative cosine of theta. Negative cosine of theta. We call it the supplementary angle formula. We are going to prove Apollonius median theorem here. For this theorem, I use this formula. So I say here I try to substitute here to use this formula. So I say instead of cosine of 180 minus theta, I put negative cosine of theta equals b squared minus, I factor this negative between c and m, so minus c squared plus m squared over negative 2cm. Now I try to undo this to negative. So I will see for step 1 and step 2, the left side of this equation are equal, so I make the right side equal as well. So I write the right side equal. For the first step, I have a squared. I take a factor from these two terms and say c squared plus m squared over negative 2cm, negative 2cm, and I have it for here for the step 2. I said left side are equal, so I make the right side equal as well. So I have to write the right side, which is b squared minus, it's minus c squared plus m squared over 2cm. Now I apply this negative to the numerator, so it becomes negative a squared plus c squared plus m squared, and undo the negative sign in the denominator. We see I have two fractional expression. They have the same denominator, so I make their numerator equal. They are equal, so I make their numerator equal, which is negative a squared plus plus c squared plus m squared and equals b squared minus c squared minus m squared. I look at this formula, so I try to bring m and c in one side and a and b in other side. So I bring a in the right side and cm to the left side. So if I bring this negative c squared to the left side, I will have positive c squared, which this c squared gives me 2c squared. If I bring this negative m squared to the left side, again gives me 2m squared. In the right side, I have b squared. And I bring negative a squared to the right side, which is positive a squared. So we see here, we prove Apollonius median theorem here. So Apollonius median theorem says 2c squared plus 2m squared. I forgot to put index equals b squared plus a squared.